welcome you to this lesson once again. I am teacher Katimbo Richard, teaching mathematics. In the lesson before this one, I promised you that I will teach you probability and subsets, how subsets can be formed from given sets, and then getting the number of subsets as well as proper subsets from given set. Now I've come with that fulfillment of the promise. That's why I've got probability here. So the question is, what is probability? Probability means the chance that an event will happen. Probability means the chance that an event will happen. Some events are organized and actually do not take place, and others are fulfilled. So that's what you have come to ascertain today. And therefore, if events don't happen or don't take place as organized, then probability is 0. And then other kinds of probability are fractional. And the biggest probability is 1. So probability ranges from 0 to 1, and the probability becomes 0 in case of an impossible happening. It's like when one asks you that what's probability that animals like elephants started speaking English now. There is no chance that an elephant can start speaking English, and so probability is 0. So in case of an impossible event or happening, probability is 0. Then when is probability 1? Probability is 1, or it's at a climax 1, when the event is natural. For example, what's the probability that the sun will set today? That one is automatically made by the creator. So probability is 1. Probability is 1 because the sun must set every day. Likewise, what's the probability that the sun will rise tomorrow? You shouldn't wait for tomorrow. You just say 1. But certain, you just know, being natural or being a natural happening, that the sun must rise even tomorrow. It will do so. So probability is equal to 1. Other kinds of probability we are going to ascertain now are fractions, and they are parts of a whole. So you know a fraction means a part of a whole, and which fraction that is entertained in probability is only that common fraction or proper fraction where the numerator is less than the denominator. Such fractions like a half, like 2 out of 3, that's 2/3, are entertained here, where the upper number is less than the downer number. The numerator is less than the denominator. So we actually entertain such fractions in probability. So other kinds of fractions are not acceptable. And probably the decimal, if it is set in a decimal form, the decimal can be acceptable. But improper fractions as well as mixed fractions can never give an answer in probability. So we said probability ranges from 0 to 1. And the formula for finding probability is number of events out of number of sample space. Probability equals number of events out of number of sample space. Although you find many other formulae, like we say probability is equal to desired chances out of number of sample space, or desired chances out of total chance, number of expected outcomes out of sample space. So all those are formulae related to probability, but teacher Katimbo has preferred using number of events out of number of sample space. It sounds very precise. And then look at the examples of how you are going to deal with probability in your workbook or P5 first term. We find it on page 17 and up to page 22. So the discussion today is found on those pages ranging from 17 to 22. Please open it and then answer, meaning after my discussion, you can answer or you can open as you follow and see where every example falls and then use it to answer that particular activity for that for which that example is set. So I've got example number 1 that says a coin was thrown once. A coin was thrown once. What is the probability of having a head on top on landing? When you throw a coin, it can show a head on top or a tail on top. So it has got two possible chances of landing. It can show a head, it can as well show a tail. So when you're given a question like that, please list the sample space before you identify. So the sample space are those possible outcomes. So you think about a head and a tail on tossing or throwing the same coin. So we've got head, tail, head, tail. Now the question asks for head. That's why you tick. This is what's called identification of what the examiner wants. So what's the probability of having a head on landing? So it's only one head here. So this will be the number of events. What's asked is called the number of events. Then the sample space means everything that can possibly appear when you throw that same coin. So that's the total chance. So we've got probability is equal to number of events out of number of sample space. How many heads do you have here? 1. So number of events is equal to 1. Then how many chances in total? I've got 1, 2 that can appear on top on landing. So number of sample space is equal to 2. So ability is equal to 1 of the 2. 1 of the 2, meaning a half. So that's how we work out that number. Please show all the total chances. Here I've got a head and tail, and then identify the head as the question suggests, then tick and say it is 1 of the 2. So the answer is a half, and that's all. Likewise, they can ask you what's the probability of having a tail on top on landing. Still, right, head, tail. This time round, tick head, sorry, tick tail, because the one in question, and then say probability is called number of events out of number of sample space. How many have you ticked? It's only 1. The number of events is equal to 1. Then number of sample space equals 1, 2. You write here 2. Still probability is equal to a half. So any of the two asked whether head or tail, the answer will be a half. Now the difference comes in ticking. So here you tick the head, it's the one in question, and here you tick the tail, and the sample space number remains 2 to get a half. So that's how we work out that probability of tossing or throwing a coin. Now we look at this other one, example number 2, which reads, a dice was thrown once or tossed once. They can use the word tossed. What is the probability of a face with a 2 showing on top? A dice was tossed once. What's the probability of a face with a 2 showing on top? Now, when people are playing Ludo, there is that solid which has got dots from 1 to 6, which is actually tossed every time and somebody plays the same Ludo. So that's what's called a die. Sometimes called a die. Here we've called it a dice. So when you see a die that was tossed, you just know the meaning of that dice. Now, the probability that's being asked is having a 2 showing on top. Now you list all the total chance that when one throws it once, what is likely to appear. So 1 can appear on top, 2 can appear on top, 3 dots can appear, 4 can appear, 5 can appear, as well as 6. And now, you identify what is the question. Add 2. So how many 2's do you have? Only 1. You tick that 2. And then that one will make the number of events in the question. Then the number of sample space will be all total chance, or total chances, as 6. So say probability is equal to number of events divided by the number of sample space. Where number of events, we have got one happening with a 2, that's a 1. Then number of sample space, count all of them, 1, 2, 3, 4, 5, 6. They count themselves well. So number of sample space is 6. Then probability is equal to 1 out of 6. Please list all the sample space and then identify a 2. It will be the number of events, which is 1. Then number of sample space, there are 6. And then probability is equal to 1 out of 6. In so doing, you will have answered that probability about tossing or throwing a dice. Then part B says, what is the probability of a face with a prime number showing on top? What's the probability of a face with a prime number showing on top? You know a prime number is the number which has got only 2 factors. Only 2 factors, 1 and itself. Now, if that is true, then identify prime numbers within numbers 1 to 6. And then we make the number of events. The first prime number is 2, because it has got 2 factors, 1 and 2. The next prime number is 3, because it has got 2 factors, 1 and 3. 4 is never a prime number but a composite. It has got more than 2 factors. What are then the factors of 4? 1, 2, and 4. 1, 2, and 4. So it has got 3 factors, it's not a prime number. Then 5 is a prime number because it has got factors like 1 and 5. So all those numbers that have got all the 2 factors are said to be prime numbers. You know, factors are also divisors. So when you know tables, you'll be able to identify the prime factors very well. So therefore, still list the entire sample space as 1, 2, 3, 4, 5, 6. Then identify the said prime number. 2 is the prime number, qualifies. 3 qualifies, as well as a 5. So, how many have qualified? Count them. 1, 2, 3. They will make our number of events. Then number of sample space remains the same. 1, 2, 3, 4, 5, 6. And now, since you have identified, now we start probability equals number of events out of number of sample space. The prime numbers that have come out are 3, that's 2, 3, and 5. 1, 2, 3. So number of events is equal to 3, and number of sample space is counting all whatever is involved here as a chance. 1, 2, 3, 4, 5, 6. So number of sample space is equal to 6. Thereby writing probability equals 3 out of 6. You must note that probability must never be reduced. We know 3 out of 6 is reducible by 3 and get 1 out of 2, or a half. But now, being probability, leave it at 3 out of 6. Never reduce probability. Please never reduce probability, even if it's reducible. So please leave it like that as the best answer. 3 out of 6 is the probability of having a prime number showing on top after tossing a die once. So this is 3 out of 6. When they ask you for odd number, you tick 1, 3, 5. When they ask you for numbers like composite, numbers with more than 2 factors, you will then tick 4 and 6. 1 is not prime and it's not a composite. So you tick 4 and 6. When they ask you for uneven number, you tick 2, 4, and 6. So that you get the number of events as 3. Other kinds of numbers, please identify the kinds of numbers involved here and tick accordingly, count them, count the ticked ones, it will be the number of events. This sample space number remains 6, and then get differing answers according to the question that will come your way, and you'll be able to answer all that work about tossing a die or a dice. So please line up all the sample space, then identify what is in the question by ticking, count the ticked ones to be the number of events, and the number of sample space remains the same, and then you get your probability in a fractional style. Then go to example number 3 today that says, in a bag, there are 4 ripe and 5 unripe mangoes. We've got a bag where there are 4 ripe mangoes and 5 unripe mangoes. Now the question says, if a mango is picked at random, what is the probability that it is ripe? Now, we have got a word which is random selection. Random selection is when you have got a container, like a bag, where you put some objects, like mangoes are in here, mix them up, and then you pick or put a hand in it without necessarily looking into that bag or container, and pick out one by chance. So that's what's called random selection. That is picking from a particular container without necessarily having that sight. So don't look into that container, just pick by chance so that it is probable, so it's probability. So it's just by chance that you are picked up, because I said probability is the same as chance and means the chance of an event happening. So now, we've got ripe mangoes and unripe ones. We've got those that are 4 that are ripe and those that are 5 that are unripe. But we shall find out that we've got 9 mangoes. 4 are ripe and 5 are ripe. So the 9, that is the total of 4 and 5, or the sum of 4 and 5, that's 5 plus 4, or 4 plus 5, you get 9. So that total number makes the number of sample space. So the number of sample space is 9. Now, of the 2 kinds, ripe and unripe, what is the question you need? It needs a ripe mango picked at random. So now, since the ripe ones are 4, then number of events is going to be 4. If they had asked for unripe, you would use 5 as number of events. Then number of sample space means the total number of the content in that container bag. So therefore we do add 4 and 5 to get the number of sample space, and the right ones being 4 to be the number of events, because the question is asking probability that the picked one at random is the ripe mango, and whereas the right ones are 4, the number of sample space is 4. So we say probability is equal to number of events divided by number of sample space. As I said before, number of events is 4 because of the 2 they need the ripe ones, and all the 4 have got a chance to be selected because they are under that category of being ripe. So we take 4, the number of sample space means the summation, the total of whatever is inside, the total content into the bag, that is 4 plus 5. So our number of sample space, when you add well, you get 9. So probability is equal to 4 out of 9. As easy as that. So when you are given a number which has got numbers like here, 4 as a number and 5 as a number, please do add to get the number of sample space. Then to get the events number, please look out for what the probability requires you of getting. Find the probability that it is ripe, or the chosen one or picked one at random is the right one. So look out for the right ones, and their number is 4 to be the number of events, and then the number of sample space and whatever is inside, and get it to get the probability finally as 4 out of 9. In that way, you have answered that. So that's about probability, which you are going to answer very well in that workbook. Starting with page 17, you move properly, and then you go up to page 19, you'll be able to answer all the questions properly. If I look at this activity, it says in a basket there are 6 ripe and 3 green mangoes that is being unripe. What's probability of picking a ripe one? You get a number of events as 3 because the ripe ones, are 6. The ripe ones are 6. Then a number of sample space, add 6 and 3 and get 9. You get 6 out of 9 at last. Number 2 says there were 4 red and 3 green pens in a box. What's the probability of picking at random a blue one? Now I've got red and green, but the probability being asked is for a blue. We don't have any blue one here. So this one, you are going to say probability is called number of events out of number of sample space. The colors that are in this box are red and green, but the question is asking for blue, meaning there's no chance. So we say number of events is equal to 0 because we don't have any color that's blue. We have red and green only. So then you say number of events equals 0. Then number of sample space, add them and say 4 plus 3. Number of sample space is equal to 7. And then you say probability is equal to 0 out of 7. Don't leave it like that. You say probability is equal to 0, meaning there's no chance of picking one. And the rest of the numbers can be read properly. Like example number 4, there were 20 boys and 30 girls in P.5 Wise class. On page 19, please. There were 20 boys and 30 girls in P.5 Wise class. If a pupil is picked at random, what is the probability that the pupil picked is a girl? Remember, I've got 30 girls here and 20 boys. So now number of events will be 30, and then number of sample space will be 20 plus 30, which is equal to 50. So probability for picking a girl will be 30 out of 50. So things of that nature, very easy, are they? Please do answer accordingly as teacher has discussed. So that's about probability, which means the chance of an event happening. So we shall then put it at that before we look at subsets now. The question is, what's the subset? A subset is a small set got from a big set. So that's what's described very well here and say a subset is a small set got from a big one. And the symbol for a subset or for subsets is this one. Say show a symbol, draw a symbol for subsets. Please show that one. It's a prolonged C. Something like C but prolonged. Don't use C but something prolonged. It's long C. Then we look at examples about subsets, and then we shall be able to answer everything about subsets. I gave you around 4 examples today, and then you'll be able to answer. Question number 1 says, draw a Venn diagram to show that set M is a subset of set N. Draw a Venn diagram to show that set M is a subset of set N. Then you must know what a subset is, and then you apply that one. So now, if set M is a subset of set N, and the subset is a small set got from a big one, then M is smaller than N and is inside N. So therefore, draw one circle inside the other, and then that small set M is put inside the other, which is N, so that M is a small set got from N, and this is just that. Please draw like that and show M and N. Be careful not to interchange and put M outside. No, N is a big set and M is a small set got from N. So subset means a small set. So you draw like that, put M inside N, and then that's all. Other questions that are related to this one, they will say, draw a Venn diagram to show that all cats are animals. Draw a Venn diagram to show that all cats are animals, meaning cats are a subset of animals. Not all animals are cats, but all cats are animals. So you use C as a small set, that is where M is, write C, and then capital A outside, so that all cats using C are animals using A. So be careful. All cats are animals, and not all animals are cats. And all other things will be brought. We say to show that all boys are males. This time B will be inside and M will be outside. So B means boys in that way, and A will be meaning animals. So that boys are a subset or a small set got from males. So M it will be outside, meaning it means males. So all boys are males, but not all male creatures are boys. Be careful. So related questions that you may find into your book, or actually not in your book, but you will find in the examination, those are actually given as examples. Then go to example number 2 about formation of subsets from a given set. It says, if set N equals these members B, C, list all the subsets of set N. Form all the subsets through listing from set N, which has got members as B, C. I said a subset is any small set that can be obtained from a big one. And it should be noted that the first subset of every set is an empty set, meaning you open the curly brackets and close without any member listed. It will be a memberless set. So that empty set is the first subset of every set. And again, we have got a law that tells us that every set is a subset of itself. So it's the last subset. It's the last subset. Although it's not a proper subset, it is the last subset. So we shall list this last, much as a subset is a small set got from a big one. There's a law that tells us to include that very set at last. But among the proper subsets, it will not be listed. So when you say proper, leave it out. When they say subsets, please include it because of the law. So now we go. We start listing. We start with the first one. The law requires of us to start with, that is the empty set. Now we get one there, B. We get another one, C. Then the last one, B, C. So here I've got 4 subsets there. 4 subsets. Empty set, B, C, then B, C. If you had been asked to list all the proper subsets, you would list only 3. As soon as they say proper, this is not proper. The law requires us to write it there, but it's not a proper subset because in definition, a subset is a small set got from a big one. So you cannot tell me that the whole set can be a small set of itself. So it cannot be. So, but because of the law, we write it there. The law tells us at last we include that one. We just add here. So just say, please let us write it, but we know it's not proper. So when you say list down the proper subsets, exclude it. You say empty set B, C. So you have only 3. So they will say by listing, find the number of subsets. You list them and then write 4 subsets. Another question says, by listing, show all the proper subsets. Find the number of proper subsets. You list this, and that. Don't list that if it is proper, and say 3 proper subsets. So the proper subsets are fewer by 1 because I've said this is a subset because of the law, but it's not a proper subset. So get to know about subsets and proper ones before we look at number 3 or example number 3. Example number 3 says, given that set T equals 2, 5, 7. 5, 7. Then the question tells you to find the number of subsets. This time find the number of subsets. They haven't asked you to list. If you are told to list, then you list like I've done and then count. Now, if it's just listing, you list and go like I've done number 1 and number 2. But now here find the number of subsets. I told you we can find the number of subsets by use of the formula, and here it is. Number of subsets is equal to 2 index n, or 2 to power n, or 2 exponent n, depending on how you want to read it. You can say power n, index n, or exponent n. But remember, it's not 2n, it is 2 index n. This is the power of 2. So, number of subsets is equal to 2 index n, where n means or stands for number of elements in a given set. N stands for number of elements in a given set. The given set is T. You must count the elements in set T. Now count them 1, 2, 3. So set T has got 3 elements, which will be a replacement of that n in the next step. That's why here I've got 2 index 3. 3 comes from these elements here. Replacing n, which n means number of elements in a given set T. So we count 1, 2, 3. So instead of n now write 3. Where 2 index 3 doesn't mean 2 times 3. Be careful. You write that 2 repeatedly appearing those 3 times. 1, 2, 3. So we multiply. That 2 cubed can be expanded like 2 times 2 times 2. Be careful not to say 2 times 3. You say 2 times 2 times 2. And now start multiplying accurately. I know you have the tables in your head. That is 2 times 2 is a 4. That 4 I've got here. Times 2 you get 8. So there are 8 subsets that can be got from set T with 3 members. I repeat, number of subsets by the formula equaling to 2 index n, where n means number of elements in a given set. Which given set this time is T, and how many elements are there? 1, 2, 3. So where n is, replace it with 3, and then expand. Write 2 cubed in expanded form. That's 2 times 2 times 2. Don't write 3 anywhere. It is 2 appearing those 3 times. 1, 2, 3. So that is 2 times 2 times 2. Where 2 times 2 is a 4. Then 4 times 2 you get 8. Then how many subsets does set T contain? It contains 8 subsets. Before we look at example number 4 that concludes today's lesson about probability and subsets. Says if set K equals OPQ. If set K equals OPQ, find the number of proper, be careful, not the word, find the number of proper subsets. In number 3 says find the number of subsets, but this one says find the number of proper subsets. Like I was explaining, with the proper subsets, we exclude the last subset, which is the whole set, and then we take away that one. So that's why the formula for number of proper subsets is equal to 2 index n minus 1, as opposed to number of subsets, which is just 2 index n. Compare those two. Number of subsets 2 index n, and number of proper subsets is equal to 2 index n minus 1. And now n stands for the number of elements in a given set. The given set is K. Count the elements in set K. 1, 2, 3. You say 2 index 3 brackets minus 1. Then expand, like we've expanded here. 2 times 2 times 2. Put it in brackets minus 1. And then 2 times 2 is the 4. 4 times 2 is 8. Now minus 1, where we've got 7 proper subsets. So the subsets are fewer by 1 subset, which is the mother set, which is not a proper subset but a subset in law. Be careful about proper and just mere subsets. And like I said, you must note that n stands for the number of elements in a given set in this formula. And now, which when used, you will be successful in getting subsets and number of proper subsets. I am teacher Katimbo Richard has taught you that much. For more information about what I've explained or what I explained before this kind of video, you call this same teacher Katimbo on 0776 25 1655, all on Airtel 07572 33066. Otherwise, stay safe.